Unit 3 practice test numbers 14 and 15. We are given an equation for the derivative of f of x. And 14 asks for how many points of inflection we have, and then 15 asks for where we have relative minima. Either way, we want to graph this function. So we want to graph, and then keep in mind that this graph is the derivative of f. So we've got x minus 4e to the negative sine 2x. Might want to double check, make sure you're in radians mode. We are. Notice our interval is only from 0 to 2 pi. So I'm going to go from 0 to 2 pi, go a little bit less than 0 so that you can see your axis there. I'm going to keep my y's negative 10 and positive 10 until I graph, and then I might change it. It doesn't look like we need to change it. Looks okay. So from 0 to 2 pi, we have our graph. This is a graph of the derivative. We are asked how many points of inflection we have. So points of inflection occur when the second derivative changes sign. So I need the second derivative to change sign. The second derivative is the derivative of this graph. This graph is the first derivative. So the second derivative would be the slope of this graph. So I need to find out how many times does the slope of this graph change. So the slope of this graph is positive, and now it's negative. So I have a point of inflection right there. Now my slope's negative and then positive. I have a point of inflection here, and another one here, and another one here. I have 1, 2, 3, 4 points of inflection from 0 to 2 pi. Explain your answer as long as you're stating that we are looking for a change in sign in the second derivative. That should be good there. Number 15 asks us to find when we have relative minima. Find the x value of all relative minima from 0 to 2 pi. Minima occur, we have a minimum value when f prime of x changes from negative to positive. Basically, the function was decreasing and then increasing. That's going to give us a minimum value. This is a graph of the derivative. So I need my derivative. I need this graph to change from negative to positive. So this graph is under the x-axis. So the graph is negative until this value right here, and then it changes to positive. Now my graph is positive, changes to negative. That would be a relative maximum. And it's negative, changes to positive, so this value here. So we need to find this value and this value. Those are the two x values where I have relative minima. So I need to calculate the 0. This one is in between 1, 2, 3, and 4. So my left bound is 3. My right bound is 4. When it says guess, I can just push enter again. 3.247. And then we have this value over here. It looks like it's around 6, might be a little bigger than 6. Calculate the 0. It's definitely between 5, and I can't go out to 7 because 7's off the graph, but it's between 5 and 2 pi. No, I didn't like it because 2 pi is right on the end point. So my window, let's just go ahead and go up to 8 here. So there's the first minimum value, that's a maximum, that's the minimum value I'm trying to find. So it's between 5 and 7. From 5 to 7. 6.068.